All right, well, cool. Well, I'm sure we'll have more signing on here in the short term, but I'm going to go ahead and get started. I'd like to thank everyone for attending the long coffee break. Again, we're going to do this in a weekly fashion, and we've got a good lineup coming for the next month, solidly at least. So expect more invitations from me, and I hope that you can join as we move forward. Just to let everyone know, we're going to record this session. We publish these on YouTube afterwards, and I'll get you a link to that once we have everything edited down that you can then send to other people within your firm or others that you think is interested in this particular subject. Please do, and would love to have more exposure on that. But again, welcome to the weekly coffee break. We're going to ask you to hold all your questions until the end of the presentation. If there's something particular you'd like to ask that comes up as Sterling is talking about it, just enter it into chat, and then at the end I'll be able to ask those back of Sterling. Sterling Minter is with us from AQC. He is the Director of Sales for AQC, and just to note, AQC is the general company that makes the duct that we might be referring to today, but those are broken down into three pieces. There's Q duct, which is outdoor duct, PAL duct, which is indoor duct. Both of those are phenolic type. And then what you may be most familiar with is Blue Duct, which is an AQC product, which is exclusively underground ductwork. So Sterling will go through this presentation, but again, just type your questions in the chat, and Sterling, whenever you're ready.
Okay, well, I appreciate that, Jeff. I appreciate Long and everyone for joining us today. So our topic this morning for you folks, afternoon for me, is duct leakage, HVAC's dirty secret. And so we want to start off with talking about some of the myths that duct leakage really doesn't matter because the cost of a CFM is minimal, because the effort to stop that duct leakage is too great. The ROI is not a good return. So you spend an extra 20%, it takes too long to recover it. We've been using insulated metal for years. We know what we're dealing with. We know how to handle it. The real issue is insulation. If we could just get some good insulators to insulate the duct, we'd solve all the problems, add a little extra R value, and we won't have any issues. Especially if it's leaking air inside a conditioned space. Well, it's still in the space, so that doesn't matter. And that's just not true because it's leaking generally up high, and so it's never coming down to where the people are. It's either already hot, so it's staying up there, or it's releasing in the hottest area of the room, so it never makes it all the way down before it cools back up or heats back up and goes back up. And then we think a little maintenance can fix everything. So let's address this CFM cost. That's generally what gets compared to. On average, we're looking at about $450 to $550 a CFM is the value of a lost CFM. If we look at typical SMACNA Class 6, that's your 4-bolt, your TDF type flanges. At 1-inch static, you're going to be looking at 6 CFM per 100 square foot of duct lost. $30, no big deal. 4 inches, we're looking at 17, 100 square foot of duct, $85. Again, no big deal. But let's keep that compound interest theory in mind that when we lose that, we have to make it up. And when we make it up, we're going to lose some of that. And so it continues to escalate. If we take a project like this Cloquet School District in Minnesota, 23,500 square foot. And so at a Class 6 metal duct leakage, which was what they had previously, that was now being replaced after less than 9 years, they're spending and losing $7,000 at 1-inch static, which we know this one ran around 6. At 4-inch, they would have lost about $20,000 annually and just lost CFM. And so it starts to add up. If we just take that then and look at a Class 1 leakage, now all of a sudden, at 1-inch static, we're only losing 1 CFM per 100 square foot, $5. And at 4 inches, we're going to be losing 3 at that 100 square foot, so $15. So now all of a sudden, instead of $7,000 being lost in CFM wasted, we're only losing about $1,100. And at 4-inch static, we're only losing about $3,500 versus $20,000. So right there's the huge savings that you're going to see and you can equate. And AQC on our website has an energy calculator. And with this calculator, we're able to help you not only determine what that value is going to be, but to also determine the kilowatts that can be saved if you're looking for energy rebates from your utilities providers. So anyone can go to our website, click on this energy calculator, And I do have several screens, so I'll look away from time to time. And with that, you put in the project name, you put in the ID, you simply go to the state that you're working in, and you click on Utah, and then you go to Salt Lake City. And with that, we've automatically programmed the cooling days, heating days based on SMACNA and weather data reports. We've already put in the natural gas average rates for the state, the natural electric for the state. You put in the square foot, and then you put in the standard type Q duct system, which is our rooftop duct system, what this was designed for, and at R12. And then you can put in the typical metal flange, SMACNA 6, same R12. You could even change it to 24, and you're going to see the Q duct is going to far outperform it, even doing that. Now, when you get your report, it tells you the kilowatt hours right here as to what's being saved if you want to go for energy rebates with the local utilities. So if we look back at that Cloquet school, just at a 6 versus a 1 on a 4-inch static pressure, we can see here this job was about $230,000 saved over 10 years. So the other project with when it was metal didn't even last 10 years. So it's a huge savings. And part of that is because insulated Class 6 metal duct is not a solution. It's the problem. Class 6 duct leaks, always has, always will. It's not meant to be as airtight as it should be. And when you put that duct outside or you put that duct in the ground and you get water infiltration, you've got bigger problems. You have flanges that are not insulated. You can see here when they pull duct, even on the inside, they pull the insulation tight. Well, if that fiberglass gets compressed, there's no thermal value. You start to lose it. So an R10 becomes an R2. When you put that outside, now you have even bigger issues, because not only is the air getting out, but we have to be concerned and understand that if the wanted stuff, the air conditioned, is leaking out, that the unwanted stuff is going to leak in as well. And so now we have big problems, because once that insulation is wet, it loses 85% of its thermal value. It starts to create mold and mildew. And we have to understand just increasing the R value isn't going to help. We've done that for the last 20 years. Instead of R8, we've changed code for outdoor duct to R10. Instead of R10, we change it to R12. And we question ourselves and we say, why is it not making a difference? It's because insulation was never intended to stop the duct from leaking. Air gets out, water gets in. We're basically putting big fancy ambulances at the bottom of the cliff with additional insulation, as opposed to just putting a fence around the top of the cliff in the first place. Stop the duct leakage. If you have 3 inches of wet insulation, you're no better off than 2 inches of wet insulation. Picture yourself, you're out fishing, you got a sweater, you fall in the lake. You're not going to be any drier if you have 2 sweaters on. So you have to solve the problem. The true cost of leakage is not just that CFM, not even just that 200,000 we were looking at on the Cloquet school, but it's the cost of the lost thermal efficiency, reducing your thermal efficiency. It's the cost of the biological growth that then takes place that you have to compensate for. It's the degradation of the duct because of water exposure. It's the increase in required maintenance. These are all things that force us to a point where we need to look at a paradigm shift. We need to stop allowing Class 6 leakage, and we need to demand SMACNA Class 1 leakage. We need to reduce the leakage so that we can reduce energy consumption. We can eliminate water in the duct. We can reduce the opportunity for mold and mildew, thereby improving the indoor air quality, which is going to reduce the need for long-term maintenance. Now, as Jeff mentioned earlier, we have 3 product lines at AQC. We have Blue Duct, an underground duct system, PAL Duct, an indoor phenolic system, and Q Duct, a rooftop system. Blue Duct typically competes with FRP, which is a decent competitor, works pretty well actually. The problem is it often is not a complete system. It has to transition to metal, and that never works. There's toxic resins, it's not recyclable, there's temperature variances. The PVC coated, you'll see I have that in small print. They're not really competition. You should not be putting galvanized duct in the ground unless it's going to be encased in concrete and insulated. And even then, it should really only be if it's for exhaust. So when the duct rusts out, you'll still have air transference. You'll see here with the blue duct, it is a complete system. It goes from the main trunks, the trunk lines out to the branches, up through the linear diffusers, diffuser bar grills, or into the units themselves. So it is a complete system. On our rooftop system, again, they're not all equal. A typical insulated metal duct system, galvanized duct, that insulation is going to get wet, that duct's going to leak, and you're going to have issues. You're going to have support areas that leak and cause leakage that get that insulation wet. The first one to come on the scene with phenolic was Thermoduct. It's a great job. Unfortunately, they too did not account for the 4-bolt leaking flange, and so they have the same issues. With the Q-Duct, we've created a double layered system, and we've done that by basically building a double wall duct with aluminum inside, aluminum outside, phenolic closed cell foam on the inside. Once we build that duct, we build a second duct around the first duct. And that allows us to offset, creating a patented Q-lock, male-female interlocking joint. With that, we get a class 1 Q-lock leakage, less than 0.5%, no metal flanges, no thermal breaks. We have 4 layers of aluminum separated by 2 layers of phenolic closed cell foam, and then wrapped with a 6-ply zero permeable jacket. So Q-lock, you can see there you have your male-female interlocking joint. That's going to be at every location with the exception of your connection to the unit, which will be flanged, and your connection to the roof curb. You have QRail, which is another patent pending function of what we've done is attached side rails to the duct. It is reinforced and attached to the internal structure that's required by the SMACNA standards. And that allows the contractor to attach to those support rails and not have to screw into the duct at any point. We've already done that. We've already sealed it. And so that allows us to get a completely sealed system. In addition, we have what's called Q-shed. Now, after we've built the Q-duct, we'll then put a sloped roof, 1/2 inch per 12 inches across the top of that duct, and then rejacket it again on the top. So you actually get 2 levels of external jacketing on top of the entire system. It gives you an R20 on your rooftop minimum, and then you get R12 on the sides and the bottom. And that energy calculator we showed you before will show you that it will outperform, even without the sloped roof, even any other system with double the insulation. Now, when we look inside, we have PAL phenolic. The only phenolic in the U.S. is Kingspan Cool Duct and Kingspan PAL. They're both owned by the same company. We represent PAL. We only do all the manufacturing, so we control the quality. It reduces leakage. It's closed cell, improves indoor air quality. It's lightweight. We don't have as many problems interior-wise, so it's less often used, but MRI suites, surgical centers, places you don't want fibers in the airstream. Additionally, you want to look at areas where you have weight conditions, you have tight ceiling grids. These are great applications for that. So with that, I want to hopefully thank you for joining us, and hopefully you'll look at using Blue Duct and Q Duct in the future. You'll be able to talk to any of your long representatives, and they'll be able to get you detailed specs and data and anything you could possibly need for this project. And so I'm going to turn it back to you now, Jeff, and see if we have any questions. And I'll just close out with a slide here, kind of pointing them to the next presentation you're going to have.
I appreciate it, Sterling. Really well done. If you can mute, I'm getting a little feedback on your end. Again, if you have a question, please enter it into chat. Would we be happy to address whatever questions you might have? I do often wonder why we aren't more concerned about duct leakage. The leakage that is prescribed now and that is in many engineer specifications has remained very consistent over the past 20, 30, 40 years. The systems we have in putting these together outside of a traditional metal build has changed quite significantly, like with the introduction of these phenolic ductwork, and they are phenomenal systems. Every time we've had installation of these, especially with underground ductwork, the contractors have always given us the feedback that they will never install anything else underground. It already comes as a pre-insulated system. It goes together with non-toxic materials, and you'll see a lot of that similarities with these other ducts. And I really do believe that the low-hanging fruit we've got from this type of system is the duct leakage. We worked so hard in order to maximize the efficiencies of the rooftop units that we're using or the central systems that we might use. Why would we throw 5, 6, 10% of that away in the duct? Why is that okay by everybody? we certainly do have these systems now that allow us to prevent that type of leakage, prevent that degradation in the efficiencies of the systems. And it's probably a good time to consider using them in a more widespread basis. One question I'm often asked, Sterling, is when we have to make changes to the ductwork, let's say we're installing a pile inside the system, and we've got a beam that's in the way, something that wasn't planned on before, a sprinkler head, something of that nature. How easy is it to make those changes after product gets to site?
It's fairly simple. We teach how to make slight modifications to shorten the duct, to make the transitions you're talking about, to get underneath. If we have the time, we'd always prefer we order a new piece. But if we need to make adjustments, that can be done. AQC trains the contractors on every product installation through webinars and on-site training. And that's one of the things we go through, is if you need to make an adjustment, how they would do that. Typically, if they need to order a new piece, it can be done relatively quickly. But we do teach them how to do that as well.
Yeah, field modifications is something that we certainly dealt with in the past, and this product is a lot more like carpentry rather than sheet metal. If you can do some woodworking, it's easier to make those transitions, and it's a much more forgiving medium that we see as opposed to the sheet metal in the past. Now, Sterling, you did mention that standard ductwork usually has a Class 6 leakage. What kind of leakage should a designer expect from the phenolic type ductwork, either indoors or outdoors?
Well, your typical phenolic system on an indoor system, medium pressure and lower, 4-inch and less, depending on whether you're looking at a butt joint connection or a flange connection, you're probably looking at 1% to 2%. When you start looking at the rooftop, again, it goes back to what type of flange. So with Q duct, you're going to see a Class 1, less than 1%, which is what you should be attaining when you're outside. If you look at the other phenolic systems, they still use metal flanges, the same as sheet metal, 4-bolt and the TDF. They're still going to leak a Class 6. So you have to put in there to pass a Class 1 leak test, be it 20%, 10%, whatever the material is. And you need to specify that it passes those leak tests after it's been connected to the duct supports. Especially with metal, they'll set the duct, they'll leak test it. Then when it passes, they get it to pass, which has only been Class 6, they'll then screw the supports into the side of the duct, and it can no longer pass that leakage. So typically rooftop Class 1, less than 1%. Interior, I would say you don't have that interlocking joint, so you're probably looking at about 2%.
And last question I have, Sterling, when it comes to seismic or wind loading on the duct, especially outdoors, any concern with these new types of systems?
No, I mean, seismic deals with a lot of weight and swing load and that type of thing. Wind loads, hurricanes and that type of thing. All these functions fall down as part of a function of the duct supports. So a Miro, for example, would be a good choice for using external applications. They take the size of the duct, the weight of the duct, and they determine how often you need the supports connected to the roof deck to maintain whatever wind velocity you're trying to do. Vibroacoustics is another good one that would do that. These are things, Vibar, these are folks that do that as part of their function of what they're providing. It's not a function of the actual duct itself. So it's pretty simple to have it figured out by a third party.
Well, very good. Well, I'd also challenge a lot of engineers, contractors that might be viewing this video to go buy a FLIR camera. It's a pretty inexpensive investment, a couple $100. Hooks right up to your Android or iPhone or even an iPad, and look over the system as it's running. We do air barrier and pressure door tests on homes. There's a lot of air sealing that goes into it, not just insulation. They're talking about an entire envelope. We even do that for non-LEED rated buildings for their exterior envelope. Buy that tool and focus in on the ductwork. It'll show very clearly where that leakage might be, especially if you have anything over a 20-degree delta T as it's running, if it's a positively pressurized system. And you might be quite surprised at what a little bit of leakage might do and show up on that type of device. I think it's pretty interesting, and I've just used it recently on another project where it showed a lot of that. So again, we have prime movers like exhaust fans, supply fans that are moving vast quantities of air, a lot of them just to evaporate into either the outdoors or into a suspended ceiling system, and then gets entrained back into the return air. It's almost like having a VVT system on every one of your systems that you might have, where it's just bypassing air, tumbling air around the building that is not doing any real work for you. And then, of course, any detriments we might have from a heating or cooling standpoint and the work we take to condition that air, we want to try and do everything we can to make sure all of that gets to the space, which I think is really what AQC and this whole duct leakage question is about. Well, I thank you all for attending and your time and attention. Anybody here at Long would be more than happy to talk with you about specific applications. So please do call and we can walk you through the process. There's a lot of guides that AQC is able to give you in order to make this as easy as possible. And as we continue forward, what is here, no fault of Sterling whatsoever, is actually what we're going to be presenting in 2 weeks. Fans Reimagined by QPAC is what we're going to talk about on the 25th and actually on the 18th. And this is my fault that we have the wrong graphic up here. We're going to be talking about Atmos Air, which is a fascinating newer offering in bipolar ionization for cleanliness indoors, both in dust, molecules, coronavirus, smoke, odors. It goes quite a way. So please join us at this same time next week. Thanks all for coming and have a wonderful day.